let's dig a little into using time value of money to solve for interest rates or number of periods. We've looked at present value, future value, payments, but these last two kind of stick out a little bit. And they stick out for really two reasons. The first reason that they stick out is that the math for these, the algebra for these gets really tricky really fast. So we're going to use Excel as our baseline to find some of these answers. Let's go ahead and go over the problem first. So first, we're going to solve number of periods. You take out a $300,000 mortgage at 6.75% annually. You want to pay this note off, contributing an extra $200 each month. How many months until the note is paid off? So this is a classic solve for in problem. We know that if we pay the required payment, 360 months, right, 30-year note, we're good to go. But what if I pay this note a little early? So what we're going to do then is let's go ahead and move forward and kind of solve some of these pieces. First up, we know we have an annual rate of 6.75. We need to divide that by 12 to find the monthly rate. We do that, we take 0.0675, divide by 12, you get 0.005625. All right, so that's going to be your monthly interest rate. We can use Excel to solve time value of money problems around payment, around the number of periods, and around interest rate. So what we're going to do is we've got a little calculator, and we're going to use that to find payments. And if we go back to the problem, it was we borrowed $300,000 to buy a mortgage at 6.75%. So the first step to the problem is to find what is our mortgage payment going to be. In an Excel spreadsheet, we can put $300,000 as PV. It's positive because we borrowed the money. The rate, we can put 0.005625, and we got that by taking our 6.75 rate and dividing by 12. 360 periods. When the note's paid off, there's 0 future value left. And we pick ordinary annuity. And we put that in. We solve for payment, and that's going to be equal PMT. And you can see when you do that, all the formulas there. And we wind up with negative 1945.79, and that's what's leaving our wallet. That's part one of the problem. Part two of the problem said, well, let's go ahead and solve for number of periods. And we can do that by saying, okay, we know we're going to take that 1945 and some change, add 200 a month. So negative 2145, 300,000 starting. We have our payment. We have our interest rate. Again, nothing future value left at the end of the note. Ordinary annuity, and we find 275 months is what's left. And if you want to solve that, you can do equals NPER, and that gives you the number of payments. All right, so far, so good. And that's going to give us the first question answer in that module. Now, the second question answer says, okay, we're going to get a little fun with it. Now I want to go ahead and pay that note off 10 years early. All right, I'm going to go pay that note off 10 years early. All right, so now what we want to do is pay that note off, but this time around, instead of putting an extra $200 a month towards it, let's just pay it off a little early. So we can go back to our payment tool in Excel. We would have the same interest rate, 6.75%, same initial balance of $300,000. The only tweak we're going to make here is that we're going to pay it off in 240 months instead of 360. And then voila, your payment is now $22.81. So we can use this tool any number of periods. You could say I want to pay it off in 10 years. I'm super ambitious. You go up to 3,400. And really anything you want to do. Once you've set up a nice spreadsheet where you have data entry columns, you have Excel doing the heavy lifting, it's so easy to dig into these time value money problems. And we can get kind of fun, right? So we've done this now. We've solved for in, we've solved for payment. Let's go ahead and solve for I. You have $10,000 in your Roth. You save $6,000 at the end of this year in the account and continue saving for 20 years. What rate of return do you need to get this account to grow to $1 million 20 years from today? Well, look at our inputs. We're going to do 20 years. We got $10,000 today. We're going to add $6,000 per year. I'm going to do that at the end of each year, ordinary annuity. And we want $1 million when we're done. So I put in the 10, I put in the 6, negative, negative, and I get back the $1 million. That would be positive. What interest rate do I need? Well, you just plug that in a calculator. It came to 16.91. Can I get that rate? No, absolutely not. But, you know, it's a good rate to talk about. So what's more realistic then? You can play around, right? Once you have that calculator built, it gets kind of fun. 16.91 is hard to do, okay? Does it happen? Yes. Does it happen consistently over 20 years? Not really. So we're going to lower that rate a little bit to 8%. And 8%, 9% is more in your long-term S&P range. So S&P being a large stock index. Now, how many years will I need to get to 1 million? So same problem as before, right? 10,000 goes in, 6,000 a year at the end of each year. I want to get to 1 million. I can earn 8%. Well, let's solve for N. So if we use Excel, we solve for NPER, number of periods. That's going to be 32.97 years. And you can see as we ratchet up the return, that number goes down. So if I can get 9%, that's 30.55, 10%, 28.51. The higher I earn, the lower the time I have to wait to be a millionaire. Pretty cool. And we'll go through Excel here in a minute and show you that off. The next one we got into was I want to be a millionaire, right? I want to be a millionaire. And what rate do I need to earn to get there? Well, in our millionaire problem, we're going to use Excel just like we have been in the past, only this time we're going to take a look at it from the standpoint of looking at a rate. In this case, we had $10,000 in a Roth IRA, so we're going to go ahead and make that present value negative $10,000. The payments each year were $6,000. We had, I believe, at first we were looking at 20 years of payments to get to $1 million. And then it was an ordinary annuity. We were funding that Roth every year at the end of the year. Now, what rate would I need to earn to be a millionaire in my Roth IRA? 16.915. Now, again, what I like about this stuff is you can play around with it, right? So you could say, well, instead of 20 years, if I had 25 years, what rate would I need to get, so forth and so on. You could also say, what if I save at the beginning of the year instead? And of course, it makes it a little easier to get to your goal. But interest rates are kind of fun, and we can play around. Now, key elements here, though, you got to get your cash flows right. 10,000 in, 6,000 in, those are going to be negative cash flows. And last but not least, we got in a little bit to the idea that maybe that's not a realistic return, right? And so we can then find number of periods in a more realistic setup. So if we have an 8% return, and we're going to go ahead and start with negative 10,000 in our Roth, and we're going to put 6,000 in a year. Our goal is $1 million. And you can see 32 years to get there. And of course, as I earn more, that number of periods would go down, right? So this is, again, using Excel, solving for number of periods, present value negative, payment negative, future value positive. And you can do any number of iterations here to find that number of periods. Once you have this basic structure down, time value money does get a little fun. And that's really how we do number of periods, how we do rates, and how we do payments.